All right, I see we've got a few people who've joined in. A warm welcome to everyone who's here. This is our online training course. Hopefully today we're not going to crash and burn like last week. I hope everyone can hear me all right. Give me a thumbs up on the chat if you can. All right. Is my audio working? Can everyone hear me?
Yes, yes. Can hear you.
Okay. Right, we're going to start in a minute or so, just so everything gets settled. Uh, hope everyone's got access to a chat window. Should be on your right. Okay. Right. So let's kick things off with a brief about me. Hi, everyone. My name's Java, and I'm an IT sales specialist here at LAN Technology. I've been in IT for well over 15 years, been doing B2B sales and business development. I've been speaking to most of you since last few years over the phone and via emails. And I'm sure a lot of you would have met me virtually via the weekly DrayTek webinars on our YouTube channel. So today's course, which is about NAT in DrayTek routers, is not only going to consist of background theory and videos, but also a hands-on demo of the practical exercises that have been covered in our workshop manual. The key purpose of the session, of course, is to equip you, our resellers, our partners, with the information that you need to be more productive in your workplace. Please do stick around at the end to fill out a survey and qualify for $100 off the reseller price, XGST, for one of the new AX routers, which is the Vega 2866AX, the 2865AX, and the Vega 2927AX. This one's going to be limited to 1 unit per participant, and the offer is valid till the 31st of August. All right, so let's start off by introducing our team. We've got a full house. I'm going to pass you on to Edward, Samuel, Harvey, Roy, and Darren, who are going to be telling you a little bit about themselves. Over to you guys.
Okay, guys. My name is Edward. I am the controller on the online workshop. So everybody coming into the workshop online, I'm gonna add you guys and yeah, monitor the chat box as well. So I've been working with Ireland for 6 years now, and maybe you meet me guys on the ticketing system, and sometimes I answer phone calls as well. So I'll pass you to Hervey.
Thank you, Edward. Yes, my name is Harvey. Been with Island Technology for nearly 5 years now. I'm in technical support and RMA repairs and all that. Today, I will give a short hands-on demo on how to do port forwarding on DrayTek routers. And also, sorry for last week. We got the Teams app stopped working worldwide, or at least in the part of Pacific, and we had to abandon the transmission. But here we are back again this week. Hopefully everything goes right. So I pass you on to my friend Samuel.
Hello, everyone. Can you hear me?
Go for it.
Yeah.
Okay. Hello, everyone. My name is Samuel. I worked for Ireland for about 7 months now, and I'm the technical support officer here. And today I will monitor the chat with Edward as well. Yeah, and now I will pass it to Roy. Yeah, thanks.
Your mic is off. Yeah. No.
Still can't.
Yeah, you can hear now.
I just had to reset
Yeah.
my microphone. Yeah. My name is Roy Panett. I'm the technical manager at Island Technologies, and I've been here in the company for about 14 years now, or just over 14 years, and I'm just looking after the day-to-day running of the support and help desk, and I'm also involved in creating these, workshop content, which I hope you'll gain a fair bit out. And I think a lot of you have met me in the past or contacted me anyway. So I'm always available. So anyway, I'll pass you to Darren. He's in Queensland. He'll tell you a bit about himself as well.
Hi everyone, I'm Darren. I'm based up here on the north side of Brisbane. If you operate in this area, feel free to get in touch with me. We do keep a small supply of stock on hand here, but we can certainly ship in as required as well. I've had an association with ILAN from the very early days. The first all-in-one Wi-Fi ADSL modem, I think that was the 2600 WE. But so I joined the team a few years ago now, and most of my time is occupied writing blogs and creating videos and so on, which I absolutely love. And so that's about it from me. So back to Jawa. Anyone else we missed? Yep, no worries. Take it away, Jawa.
Thanks, Darren. So that was our team for the day. And before we begin, I'm going to quickly go over some housekeeping items. Please do ensure that your microphones are muted during the session. We want to keep things as smooth as we possibly can. And if you do wish to make a comment, you can raise your hand and we'll allow you to speak. You can always type a question in that chat box, and the team's going to be looking at it and we'll be providing feedback during the session. During the hands-on demonstration that Harvey's going to give, you can raise your hand if you need any further explanation about what's being shown on your screen. Do note that the session is going to be recorded. Edward, we started, right?
Yeah.
All right. So if you do not wish to be viewed in the same, you can simply switch off your camera. The next few slides, I'm going to go over some tips on using Microsoft Teams in case you may not be familiar with the application. I know most of you have attended our workshops before, so I'll keep it real quick. Okay, you see up top your Teams window. There's a bunch of icons, and depending on the size of your window, in the middle somewhere, it should be 3 dots. Just click on that to see all the other options available. The main one you will need is the device settings. And in the newer version of the Teams app, and in the web browser version, which I'm using too, the toolbar actually appears if you mouse over the window. So that is going to show you your audio, the speaker, the mic, and the camera options if you're having any trouble with any of those. And towards the right up top, there are icons for the camera and the mic. If you want to turn your camera off or mute your mic, just click on those. Edward's got an override here to turn the mics off, but of course we can't turn them on for you. So if you're invited to speak, don't forget to unmute yourself. And on the left is the icon for show participants. Just click on that and you'll see everyone present in the meeting. The next one's the chat icon. If you click on that, it's going to open the chat box where you can see any comments and you can type some of your own. You can attach files and you can add emojis, GIFs, and stickers. The third one's where you can raise your hand. Please do that if you want to ask a question. And the one on the far right is the one to select to raise your hand. It is going to display your name in the show participants display where hopefully one of our teammates is going to see it and call out your name to respond. Please be aware that we're still sort of getting used to all of this. So apologies in advance if we miss seeing your hand raised. If at all that happens, please type your question in the chat box. So here's the schedule for today's workshop. After the conclusion of introduction, which has just happened, the session is going to run for about 45 minutes or so, followed by a 15-minute general discussion. Okay, so what are we going to talk about? Here's the outline for the course. We'll start by going over some background information, which includes IP addressing, LAN and WAN. This is required to understand network address translation. Then we're going to look at NAT features such as port redirection, DMZ, open ports, triggering, and ALG. And we'll also go over some additional features of NAT and wrap things up nicely with a few troubleshooting tips. So before we get into the thick of things and start discussing NAT and port redirection, it will be wise to refresh some IP basics. So please bear with us for a few slides. I promise to keep it quick and relevant. Here we go. In an IP-based network, each device, that's a computer, printer, server, a camera, or a telephone, needs a unique IP address to identify itself on the network. And when we talk of IP addresses, there's two types, public and private. Public IPs are used on the internet, and private IPs are used inside your local area, and they do not connect to the outside web. Here we have the private IP address ranges, which are reserved for use on internal networks. Different sites may use the same IP address over and over again, as long as they don't communicate directly with each other. But once they start to connect together, for instance, when you're using VPNs, it becomes necessary to have separate sets of IP addresses or using the address translation. Now, the IPv4 set of IP addresses, which is 32 bits, has a limited number of addresses, specifically 2 to the power 32, which is approximately 4.29 billion. And although it's a big number, we've run out of those. And which is why, for the last 15 to 16 years, network admins around the world have been trying to implement IPv6, which uses 128 bits, which is 2 to the power 128, which is 340 trillion, or this ridiculously large number that you see on your screen. So this change to IPv6 is still under development today. And we do not have much choice as the number of IoT devices is increasing exponentially. We've essentially hit the ceiling for the maximum number of IPv4 addresses since 2017 for Africa and 2019 for Europe and Middle East, and even 2011 for Asia and the Pacific region. There are some individual ISPs who still have pools of unassigned IP addresses and could recycle addresses no longer needed by subscribers, but that's only going to last so long. It is important to note that IPv6 isn't backward compatible with IPv4, so they can't talk to each other as such. But there is a technique called dual stacking that's going to allow them to coexist on the same network. Now here's an updated graph from google.com/IPv6 website that shows the percentage of users that access Google over IPv6 starting from 2009 to 2022. It has reached 37% and it's going up exponentially. Okay, so here's a basic LAN setup, which all network technicians should be very familiar with. This configuration's got 4 devices, and each of them has a private IP. This constitutes a typical LAN as compared to the internet, which is considered a WAN or a wide area network. In this picture, you can easily identify the 4 IP devices with addresses 192.168.10.10 to .13. Usually, these IP addresses have been assigned automatically by the DHCP server of the router. On the top, you see the WAN IP of the router is 123.24.25.1. The IP address which gets allocated to the WAN interface of your router can be either public or private. WAN connections using a USB 4G dongle mostly uses a private IP address since the modem has built-in NAT that cannot be disabled. LTE-WAN connections, when using one of the DrayTek LTE routers, will be allocated a private IP, but it can be changed upon request to the service provider. We should note that some service providers are starting to use CGNAT, otherwise called carrier-grade NAT, to conserve the IPv4 address allocations. What this means is that the router will be allocated a private IP for the WAN connection. And of course, it's important to note that for port forwarding and port redirection to work, a public IP address is required for the router's WAN. Otherwise, you won't be able to initiate a connection to the router from the internet. To check the WAN IP on the router, you can check the online status page or the dashboard. In this example, on this online status page, you see that the WAN 1 has the IP address of 192.168.255.78, which is private. It means that the connection is behind an ISP firewall and cannot be accessed directly from the internet. If that's a problem, you'll need to approach your service provider to see if they can allocate a public IP address to you. However, for VPNs, this isn't really a limitation anymore because DrayTek has a solution called VPN Matcher, and we will be getting around to this problem. But before anything, let's start with a quick quiz just to see if you've been paying attention. So, what IP address is required at the router's WAN interface to allow access from the internet? Please raise your hand if you know the answer, or just use the chat box to write your answer. Is it A, private IP? Is it B, public IP? Is it C, or is it D, all of the above? Or is it E, doesn't matter what IP address is used? All right, a bunch of Bs, that's good. The answer is B, which is a public IP address. We need to remember that the WAN interface on your router should be reachable from the internet, and private IPs are usually behind a firewall or NAT and hence cannot be accessed directly. Okay, moving on, let's talk about NAT in more detail. NAT is an abbreviation for Network Address Translation, which is a mechanism where one or more private IP can be mapped into a single public IP. There are a number of benefits of using NAT, which includes saving on costs of applying for a range of public IP addresses. It helps to conserve the IPv4 address space, which is nearing exhaustion. The efficient usage of IP addresses. One internet routable IP address of a NAT gateway can be used for an entire private network. We've got large companies with thousands of computers that can also utilize NAT for the LAN and only require a small range of public IPv4 addresses. And finally, it can be used to enhance the security of your internal network by obscuring the IP address. There are many internet attacks that are based on IP addresses. And since the attacker cannot be aware of any private IPs, the NAT function can protect your internal network. Here we see a router in action providing NAT, allowing several LAN users to access the internet using a single WAN IP address. So any local users that are communicating with the internet will show the same public IP address, which in our example is 123.24.25.1. So far, so good. But what happens if we want specific traffic to be directed to a specific device on our LAN? How's the router going to know which device to send that traffic to? To get around this issue, we use what is known as ports. For each WAN IP address, there are 65,536 ports for TCP and the same for UDP. You may use any external port as long as it isn't already used by another device on the network, bearing in mind that some ports are reserved for special purposes. For instance, HTTP uses port 80, port 443 is used by HTTPS, and RDP uses 3389. So down the bottom there, we've decided that we want any external packets going to our public IP address on port 85 to be directed to the PC with the private LAN IP 192.168.1.10. Packets on port 86, we want to go to 192.168.1.11. Packets on port 87 to go to 1.12. And any packets on port 88, we want to go to 1.13. So how do we make this happen? The answer is port redirection. What it does is it allows external devices out on the web to access an internal device behind a router with a private LAN IP address. Now, here's a typical scenario where we want someone out on the internet to be able to access an FTP server on our LAN on 192.168.1.12. So FTP usually uses port 21. Any visitors who want to access our FTP server can either use an FTP client or they can just add :21 after the router's WAN IP in most web browsers. So for example, 220.135.240.207:21. Now the router won't know what to do with that traffic yet. So our visitors won't be able to access the FTP server with that information alone. We need to tell the router that any traffic coming in on port 21 needs to be directed to our FTP server on LAN IP 192.168.1.12. This setting is found under NAT port redirection in DrayTek routers and is pictured here. This is what the rule would look like. The mode can be single port or a range of ports, bearing in mind that we'll also direct those ports to consecutive LAN IP addresses as per the note down the bottom there. Service name can be anything you like. We've named this one port 21, but we could have called it FTP or anything else. The protocol can be TCP or UDP. We need TCP for FTP traffic. The WAN interface comes into play if you have multiple WAN connections and you want to direct traffic on port 21 if it comes from any WAN or only if it comes from a specific WAN. The public port for FTP is 21. The private port is also 21, but that could also be a different number if you want to get fancy and if you want an FTP server using a different port, assuming your server software allows you to do that. The source IP can be any if you want just anyone to be able to access our FTP server as long as they have a recognized username and password, or we can lock it down to a particular IP or a group of IP addresses by creating objects down under the object setting menu. Private IP is, of course, the FTP server's LAN IP, which is 192.168.1.12 in this example. So just referring back to port ranges, in a case where you need multiple host port redirection, where you have a range of IP addresses with a range of port numbers, let's look at this example. What we want to do is that we want ports 8080 to 8081 to be directed to consecutive LAN IPs 192.168.1.10 and 11 on port 80. Once we add our public port range and the start IP, the router automatically adds .11 for port 8081 to go through port 80 on the second web server. So in other words, we have two web servers that are using port 80 internally, but to get to them from the internet, the visitors will go to either port 8080 or port 8081, and the router will then send the visitor to the correct web server based on the external port used. Another option that you can use is the DMZ, or Demilitarized Zone. DMZ is an area inside your LAN where no ports are blocked. It is very convenient when you have equipment or applications that need several ports to be open, for instance, a VoIP device. Here's a typical example where DMZ has been set up on the WAN 1. So any traffic on any port is going to be directed to 192.168.1.10, which is the DMZ host. Obviously, it's going to leave the DMZ host completely exposed, but the other LAN devices will stay hidden. And to better protect the DMZ host, you can have additional firewall rules to restrict unwanted traffic. So how do we set that up? It's going to be done under NAT DMZ host setup. First, we select the WAN to be used by clicking on one of the tabs up here on the top. Then we click on Choose IP to select the LAN IP address of the DMZ host. Please do note that the option to set up true IP DMZ has been removed in later firmware versions, but you might see it on your router if it's still running an old firmware. Let's talk about this feature in the next few slides. In older routers or firmwares, you will see a menu similar to this one. Now, what if you need the public IP address to appear on the device in the DMZ? A typical application is when you've got a VIGA 130 or a 167 in bridge mode. You'll find that you lose connection when the VIGA 130, when it's bridged, because every packet is just passing through it. A solution to this is to put the VIGA 130 in true IP DMZ mode. This setting is sometimes required for users who use gaming or multimedia applications. You can see in the bottom picture that the WAN IP 172.12.18.101 is being passed onto the PC in the true DMZ area. Now, here's how you configure true IP DMZ. To do that, you go to NAT DMZ host setup. You select the active true IP from the pull-down menu at the top, and then type in the MAC address of the device in the DMZ. This is going to tell the router to pass on the public IP address to the DMZ host behind the router. And you can also use this in a case where someone using L2TP over IPsec is facing issues due to NAT incompatibility with IPsec. In this case, the VPN client will use the public IP address, and the router will pass the IPsec packets through the NAT barrier without any issues. Do remember that the feature isn't available on all routers, and it is currently supported by VIGA 130 and the VIGA 2620. An extension of DMZ host is where a router LAN port can be designated as a physical DMZ port with its own subnet. So any device connected to the port is going to be in DMZ. This is useful if you've got a large number of devices which need to be in the DMZ. And again, the feature isn't available on all routers. Pictured here on the left is the front panel of a VIGA 3220 that shows a dedicated hardware DMZ port. A common application for DMZ is when you're transitioning phone services from the old PSTN system to the NBN VoIP services. Very often, the NBN service provider will supply a basic VoIP router, which is locked into their network. And it's difficult to migrate the VoIP services to a VoIP-enabled DrayTek router if the ISP will not give you the SIP details. So the solution then is to place the ISP supplied device into the DMZ of the DrayTek, as shown in this diagram. And there is a knowledge base article down in the link at the bottom there that you should also find in the manual. So what do we do if we want to direct more than one port to a single host on the LAN? Open ports is similar to port redirection, but it allows this to happen. Just be aware that incoming ports are not mapped to a different port number on the LAN side of the router. You'll find this feature also under the NAT heading in the router's menu. The screen shows how to open ports 25 and 110 to a LAN device with IP address 192.168.1.10. Do note that the source IP can be an IP object or an IP group. Another thing we can do is we can forward a range of ports to an internal server by specifying the start and the end port. For example, ports 25 to 35 and ports 110 to 120 here are to be directed to our mail server now. Okay, so we've just covered three methods that are supported by DrayTek routers of port mapping, which can forward traffic on the router's WAN interface to a specific LAN host and make it accessible from the internet. These are port redirection, open ports, and DMZ. Also note the priority level of each method. For example, if you've got an incoming packet's port number, which matches a rule in both port redirection and open ports, then the packet will be forwarded into the local address as defined in port redirection. So how do you decide which NAT rule to use? Firstly, we have to be aware of the priority of the port forwarding rules, like I mentioned. Uh, Port redirections got the highest priority, followed by open ports and then DMZ. Redirections used when you need to translate an incoming port to a different port on the LAN side. For instance, when a server is using the same port as the router's management port, such as TCP ports 80 and 443. The range mode option is helpful when there's more than one server using the same port. Next, we've got open port, which is used when a single server has many different port numbers that need to be open to the internet. And finally, we have DMZ that's going to open everything on the LAN host for the selected WAN. Okay, super easy quiz question. What is the order of priority for NAT port forwarding rules? Is it A, port redirection, open ports DMZ? Is it B, open ports DMZ, port redirection? Is it C, DMZ, redirection, open ports? Or is it D? I'll make it easy, it's not D. Please raise your hands and you can use the chat to write your answer. Here's looking. All right, Matthew says A. Ditto for Matt and David. That's right. The answer is A. That is port redirection, open ports, and DMZ. Well done, guys. But that was too easy. So let's try another one. If I have a mail server on the LAN that requires two TCP ports, 25 and 110, to be forwarded from the internet, which NAT option am I going to use? Is it A, port redirection, B, open ports, C, DMZ, or D, all of the above? Again, I'll make it even easier. It's not D. Go for it. All right, a bunch of B's coming in. Well done. The answer is B, open ports. So we're going to enter the port required as shown here. For single port numbers, we have the starting port and ending port in the range to be the same numbers. All right. What's next? Port triggering. Okay. This is a feature in bigger routers which allows a host machine to dynamically and automatically forward a specific port back to itself. Well, what's that, you ask? Let's take an example of connecting to an IRC server, IRC's Internet Relay Chat, that needs to authenticate a username with the protocol via port 113. When you log into IRC, you typically connect to the server at a port in the range 6660 to 6670. To verify the username, the IRC server replies and makes a new incoming connection to your computer on port 113. It's not going to work if you're behind NAT because the router doesn't know which computer that packet's for. So the packet will be dropped and the authentication is going to fail. While you could use port redirection or open ports to get around this, it will mean that only one device on the LAN will be able to authenticate to the IRC server. But what if you've got more than one? So the solution's using port triggering. In this specific case of IRC, you can create a port triggering rule, which will create a temporary port redirection on the PC that made the initial outgoing request. The trigger port's the outgoing port on the application, which is 6660 in this case. The incoming port, which is port 113, are the ports that are used by the application for it to work. These are not going to be opened until the corresponding port is triggered, and it's going to be closed again after a set amount of time. This is going to give more flexibility than static port forwarding because it is not necessary to set it up for a specific address on your network. And it will allow multiple clients to connect to IRC servers through the NAT router. Of course, you're going to gain security in the sense that the inbound port will not be left open when it's not being used. All right, ALG is application layer gateway. This is a method that allows certain media streams, such as VoIP and some video streams, to get across your firewall. ALG understands the protocol used by a specific application, such as SIP, which is the Session Initiated Protocol. A NAT router with built-in SIP ALG can rewrite information within the SIP message, that is the SIP header and the body, which makes signaling and audio traffic between the client behind NAT and the SIP endpoint possible. Protocols like SIP, RTSP, and FTP often fail when the service server is behind NAT. ALG is the solution to this problem. When you've got ALG enabled, the router will replace the private IP with the public IP in the negotiation packet from the client and open dynamic TCP and UDP ports required for the connection. This screen shows you how to enable ALG in the DrayTek routers. The setting can be found under NAT in the router's main menu. It doesn't work well with some applications though. Let's talk about a scenario where you need ALG to be disabled. The customer and associated tech support for the Avaya system have said that they need to see the external IP address of the connection in order to register it. In this case, we don't want the DrayTek router to present the modem's internal address to the phone system. Some of the entries in this log show the IP address 172.16.1.222, which is the LAN address of the DrayTek router, while some are displaying in the external address in the private address field. According to the text over at Avaya, they need to be showing that external address in the IP address field and not the internal IP of the modem. How you solve the problem? Simply by disabling ALG. And Nowadays, as an update, DrayTek routers have ALG disabled by default, and you can enable it via Telnet or using the GUI. Okay, let's have a brief look into some other features of NAT. Talking about NAT Loopback, this one's a useful feature added to DrayTek routers, and it is enabled by default. This works after configuring the open ports, redirection, or DMZ host on the router. Once configured, you can use the public IP or the domain name to access the server from both your home or office network, as well as from the internet. For example, the internal web server shown in the image can be accessed by users in the local area using the public IP 1.2.3.4 or domain name that is example.com, thanks to NAT Loopback. Okay, FastNAT. This one's available in Linux-based routers, such as the Vigor 3900 and Vigor 2960. It allows specific LAN hosts to skip inspection by the CPU and go directly to the FastNAT path. What this means is that the router will forward the traffic from a particular LAN to the chosen WAN directly. By enabling this function, the CPU load is decreased and the performance of the NAT session is speeded up. However, if the traffic's going to be skipped, features like firewall will not work on FastNAT LAN. In this example, the 2960 is acting as the internet gateway for a university dorm, and there are hundreds of students accessing the internet through it at night. So CPU usage during the time is usually high. The admin would like to reduce the CPU usage and to speed up the NAT performance of the student's LAN can use FastNAT. However, an exception is needed for the VPN network to let the students connect to the campus network. One thing we should mention is that since the Vigor routers have a built-in web server for routers management that's using port 80 and 443, you need to ensure these port numbers do not clash with the port redirection or open port settings. In the example on your screen, you can see how to change the default HTTPS and the SSL VPN port numbers so they won't clash with the port redirection or open port configuration that's using port 443. Okay, so time now for a hands-on demonstration. Harvey's going to show you how you can configure port redirection to allow RDP access from the internet to a computer on the LAN. I'm going to pass you on to the able hands of Harvey, who's going to take us through that in detail. Over to you.
Thank you, Java. Well, today I will show you a simple application of port forwarding. Let me see, where's my, see, yep. So we will use port redirection to provide remote desktop protocol access to a computer on a LAN from clients on the internet. Like this, it shows this, any client from the internet can access the RDP server, which is on the LAN and using a port. But on the second exercise, we will allow only one IP address to be able to do that as a means of security. So we just add another layer. Okay. So this is our 2865. So we will do in port redirection and the NAT. And let me see. I've got a short video. I've makes it easier for you to follow. Direction. So we will now log in on a 2927 router, and we will check the one IP. We can see that it is 106.69.158.214. We will then go and create a new port redirection rule, which we'll name as RDP. We will use the public port as 11,000 and the private IP is 192.168.1.10 and the private port is 389. So see this sketch, we will connect from the router on a LAN, and the RDP we will type 192.168.1.10, and now we're on the remote desktop. You will see this beautiful background. And I will show you how to enable RDP in Windows PC. Just go to the system settings and go to the remote desktop and enable it. I have already done it before, or else the RDP would not have worked. We now close this RDP window and I show you the one IP again, which is 106.69.158.214, and see the sketch. We will now connect from any IP address on the internet. So we now have our RDP connection window. We will select the one IP address. Note that the port number comes after a colon, 11,000, and we connect. The password is requested again, and there we go. We go on the remote PC. This is our background. Good. Now we close this remote desktop, and we will now add a filter to allow only one IP address to address the RDP. So we go to the port redirection and select the existing rule. Change the source IP address to an IP object. Of course, we need to define that object, which I did before, and call it test PC, to which we add the one IP which will be allowed, which is 203.45.166.174. So we will try now to RDP using any public IP address. And when we try, nothing happens because it is not allowed. We check the one IP address is a 220.235, etc. So we try again, and we got an error message. So we will now try with a PC with an authorized one IP address, which is 203.45.166.174. Here is our remote desktop window. We log in, and immediately we get a request for password. And now we jump on the remote PC again, and we check the LAN IP address, which is 192.168.1.10 as usual. This concludes our demo on how to use port redirection on a DrayTek router and how to allow remote access from the internet using RDP. Okay, thank you for this. Java, you can take over.
All right. Thanks for that, Harvey. You can find detailed instructions of what you saw on your screen in your workbooks from pages 49 to 52, if you want to refer back to it later. Now's the best part. All right, let's quickly go over some NAT troubleshooting tips that will help you. One common issue that's reported to us is that some customers cannot access the local service from the internet, even though they have enabled port forwarding. There's a number of possible causes. More details are available on page 53 of your training manual. The first one is that some service providers block incoming ports, such as port 40 and 443. Usually, you can get into your service provider profile and change the default settings to allow those ports. Another cause is that the ports used are also used by the router's local service. So incoming connections onto port 80, for example, are going to be intercepted by the router's management page and are not forwarded to the host on the LAN. The way around is to change the default router management ports, say set the port to use port 8080 instead of port 80. And alternatively, you can use a different incoming port number. And the third tip is to check that the LAN server does respond to connection requests. Sometimes the firewall on a Windows server may be blocking the connection. Other items that you can check are that the server's default gateway must point to the router's LAN IP. Sometimes static routes or route policies can be directing the server to the wrong gateway. You can also check there are no firewall rules in the router that are blocking the connection. And finally, if all else fails, you can capture the LAN WAN packets using Wireshark for analysis to find the cause. If you're not sure if NAT and port forwarding are working, you can go to the Diagnostics NAT session table and have a look at the entries. This should tell you if the required incoming ports from the internet is seen by the router and the destination on the LAN. Another thing to watch out for is the number of active sessions. If there are torrent or other peer-to-peer connections running, they can consume all the router's resources as well as the internet bandwidth. Uh, a good way to prevent this is to limit the number of simultaneous NAT sessions. This is done under the Bandwidth Management Sessions Limit menu on the DrayTek router. Another common issue we've come across is that some internet applications will time out due to low timeout values required by the application. An example we recently came across was with Titan software, which is a cloud-based software used by car dealerships to manage their inventory. The solution was to increase the UDP and TCP timeout values by using the port map time telnet command. This one's been explained in the knowledge base article there on your screen. Okay, so that was fun. To quickly summarize, today we started by looking at TCP IP and LAN basics, followed by network address translation. We then looked at port redirection, DMZ, open ports, port triggering, and ALG. And we finished with some troubleshooting tips. Time now for a Q&A, I guess. We've got another 10, 15 minutes to go. If you want to ask any questions, please feel free to use the chat box on your right. And if at all you can't hang around, please remember to fill out that survey to let us know how we went. Please do tell us what you liked and what you think needs more work. All right, there's that link on your screen. Please fill that out. It's also going to qualify you for $100 off the reseller price for one of the new AX models, which is the Vigor 2865AX or 2866AX or the 2927AX, valid till the 31st of August. Do we have Ming online? Yeah, we do. All right. I see our MD is online as well. So, Ming, if you want to have a quick vote of thanks, please highlight him.
Yep. Hi. My name is Ming Lu. I'm the MD of Island Technologies.
Is your camera on?
Can you hear me?
Yeah,
We can
hear
hear you,
you, but your camera is off, I think.
Okay, but I cannot turn it on.
That's
I
right, sir.
tried,
We can hear you. Go for it.
Okay.
No worries.
Yep. Yeah, I want to say that in the last few years, we have been conducting all this online workshop and in-class workshop, which will return to when the pandemic situation allows. Of course, in the in-class workshop, there will be a bit products for people to try hands-on as part of the course, and we welcome everybody to join in when they are available. Before that, we'll continue on with this online workshop. The idea of customer training is not new. I remember years ago, I attended seminars conducted by Cisco. And I don't remember the subjects, but the lunch and the coffee were good. I want to thank Roy and his team of network experts for putting so much effort to prepare for the handbook, the PPT slides, the videos, the hands-on demos, and everything that's required for this workshop to be conducted. So thank you, the teams. Also, I want to thank everyone who participate here. It's you. You are the reasons for our workshops. We want to make sure that you get the maximum benefit of the DrayTek products. But we also need your feedback and comments and other questions or suggestions to help us to improve our work, our presentation, and all material that we can cover. So yeah, thank everybody for your participation, and please stay safe, and we'll see you soon. Thank you.
Thanks, Ming.
Thanks.
Wise words there. Please do stay safe. The pandemic and the last 2 years have kept us away from a face-to-face session with all of our partners and resellers. And hopefully, when situation improves, we will be able to welcome you back and be able to interact with you in person. But in the meantime, we will be a part of your days through that little screen there. I believe we do have fresh training sessions planned soon. We'll keep you updated. If you don't hear from us via newsletters, just drop me a quick email to sales@draytek.com.au and I'll add you to our newsletter list. And yeah, I guess if there are no further questions, I'll call this a session. Thanks so much, everyone, for your time. Please do fill that form, provide us your feedbacks, bouquets, and brickbat, whatever it is. And we look forward to meeting you again soon. Thanks, everyone. Bye-bye.
Okay, so I should mention before we go, they're referring to the page references on the slides to the manual. It's up on one page, so if you want to follow through afterwards when you watch the video, just add one more page to the slide, to the page number on the slides.
Mhm. Okay. See you, everyone.
Thanks for joining in. Bye bye.
Thank you.
Bye.
Bye bye.